Okay, hello again, ladies and gentlemen. I'm going to give you the solutions for the circles proofs day 2 congruent triangles homework, which was numbers 3, 4, and 5 in the notes. Let's get to it. All right, so I have them typed out here. Segment AB is congruent to ED, that's given. Okay, then I have the other two givens there, or three givens. AC is parallel to FD, and then the two perpendiculars. All right, so angle 1 and 2 are going to be congruent because perpendicular lines form congruent right angles. And 3 and 4 are going to be congruent. Okay, if AC and FD are parallel, then parallel lines cut by a transversal form congruent alternate interior angles. Okay, so then those two triangles will be congruent by angle side. Segment AC is congruent to FD by CPCTC, and then their corresponding arcs must be congruent because congruent chords have congruent arcs. Okay, that should have been pretty straightforward as far as the proof goes, for sure. And then those two extra steps there. Okay, number 4 is right along the same lines. Okay, I have the givens, the perpendiculars, and the PR bisects angle QPS. Okay, so I've got angle 1 is congruent to angle 2, perpendicular lines from congruent right angles, and 3 is congruent to 4, definition of angle bisector, and then of course RP congruent to itself by reflexive. So now those two triangles are congruent by angle side. And again, same last two steps as number 3. Segment QP and PS are congruent by CPCTC, and then their corresponding arcs, because congruent chords have congruent arcs. Okay, now number 5, we've got two proof statements. Okay, so you'll notice that some of the statements that I've made, I've done a whole lot in one, combined a whole lot of statements, and I'll talk about why when we get there. Okay, so arc AB is congruent to DC, that's the given. Okay, so segment AB will be congruent to segment DC, congruent arcs have congruent chords. Okay, angle 1 is congruent to angle 2, intersecting lines form congruent vertical angles. Okay, so that gives me those angles. Now, the next statement, which is statement 4, really has 6 statements in it, and they're all basically the same statement with the same reason, so I combined them all. And I combined them, some of them refer to the first proof statement A, and some of them refer to the second proof statement B. Okay, but anyway, 3 and 4, okay, are both half of arc AD because they're inscribed, and that's their arc AD. 5 and 6, same reason, half of arc BC, they're inscribed. Okay, and 7 and 8, the same reason. 7 is half of arc DC down at the bottom, and 8 is half of AB, the arc at the top. All right, so all 6 of those angles are halves of their intercepted arcs because they're inscribed. Now, what pieces do I need for the first proof? Well, 3 congruent to 4 and 5 congruent to 6. Okay, so I have those two pairs of angles because they are halves of the same arc are congruent. Okay, 3 is congruent to 4 and 5 is congruent to 6. They're both half of the same arc. Okay, so that gives me the two triangles in proof statement A, triangle ABE congruent to CDE by angle side. Okay, now 7 and 8, they're also congruent. Okay, the reason is a little bit different. They're not halves of the same arc, but they are halves of congruent arcs. Okay, which was our first given. Arc AB was congruent to DC. So those are each half of congruent arcs instead of being halves of the same arc like the angles in step 5. Okay, so the reasons are a little bit different there. Okay, and again, BC is congruent to BC, so we have angle side congruent to angle side. All right, so if you stretch that out and put individual statements, that's fine. I was able to combine them as I went along. I saw, oh, well, this has the same reason as the other one, even though I'm in the second proof now. I went up and put